Hey guys, welcome back everybody. Hope you all are doing great. Guys, many of my subscribers were requesting me to make some videos on SDN network, on software defined networking. So today we will discuss SDN network, SDN, software defined networking. We will see why we need SDN, what is SDN, how many types of SDN networks are there, and how SDN network works. Okay, so guys, first thing is, what is SDN network? So you can say SDN or software defined networking is a modern approach to manage and control networks. Guys, if I will talk about the traditional networking means, like you can see these branch offices, right? I have some sites over here. So traditional networking involves multiple hardwares like your routers, your switches, your firewalls, and each devices are responsible for a specific task. Like routers are responsible for routing, switches are responsible for switching, distribution layer switches are responsible for distributing the traffic, firewalls are responsible for the security, correct? And guys, at each branch we have two types of hardware, right? In the data center you can see this is my design, but we are not going to focus on the design today, right? Design can be different inside the data center or inside the branch offices, right? Like design can be design inside the data center can be a spine leaf, right? It can be 3 tier, it can be 2 tier, multi-homing. So we are not going to discuss the design inside the branch or inside the data center. Just suppose this is one network, one, you can say LAN, local area network, in the data center where we have lots of servers. All servers are connected with switches, then access layer switches are connected with distribution layer switches, and distribution layer switches are connected with routers core layer, right? Then we can have firewall, and after that we can connect it to the service provider network. So guys, here in my scenario you can see there are multiple sites. Like this is data center, this is site 1, this is site 2, site 3, then I have headquarter, I have one remote sites. In the same way I can have some application on cloud as well, right? Let's suppose there is cloud as well, right? I am hosting some application on cloud. So how these two all sites are going to communicate with each other? Definitely we need to connect them together, right? And to connect these sites together, these all sites together, what we need? We need service provider, right? We need service provider. With the help of service provider we can connect these all sites together. And here you can see we have multiple service provider, right? Like internet, MPLS, metro, ethernet, LTE, like 4G, 5G, right? Internet is definitely public service provider, but we are using it, right? So these are the transportation solutions which we are using to connect multiple sites together. So in this scenario guys, if I want to connect these all sites together, what I can do? Either I can connect these all sites together with the help of internet like this, and then I can configure the scenario so that these all sites can communicate with each other. Like in data center I have some resources, right? I have some resources, and that resources should be accessible from all sites. All sites users should be able to access that resource, as well as all user from the headquarter, from the remote side. These all users should be able to access the resources which is available in data center. And now you can see all sites are connected together through internet, so all sites can access the resources on data center. Even we can configure the scenario so that my users can access internet. But guys, is there redundancy? No, there is no any redundancy. So if internet will goes down, or if this link will goes down, right, then data center will not have any connectivity to other branch offices, correct? So this is the issue. Now we have any backup. So for backup, what we can do? We can purchase the connectivity from our different service provider as well, right? Like I can connect these all sites together through MPLS as well. So let's say my red link is connected with MPLS, and one service provider is the primary service provider, and the another one is backup, the secondary. So if primary will goes down, then I can use the secondary ISP, secondary SP, service provider. And now you can see my all sites are connected together, right? That means all sites can communicate with each other. Now guys, there is no any issue. If you need more backup, you can use Metro Ethernet, you can use LTE, right? But then cost is going to be increased. So this is the traditional network, right? This is traditional network. And guys, as network size is getting large, right, getting larger, it's difficult to manage, troubleshoot these types of network. Like, see, in this scenario I have only 1 2 3 4 5 6 branch offices, right? Suppose if I have thousand number of branches, how complicated it will, right, to manage it, to troubleshoot it, right, if there is any problem. Even if I want to apply one access control list on a router, it will be very complicated, right? If I have thousand number of branches, it will be very difficult to configure one ACL on all routers or on all networking devices, correct? So nowadays network size is growing, network is getting complex, more complex, so it is difficult to manage and troubleshoot. Even it is very difficult to add one new sites here, right, to modify the IP configuration, to modify the policies. It's very difficult, right? On all sites we have to configure manually, right? Manually I have to assign engineer for each site who is going to modify the configuration, who is going to apply the policies or the access control list, right? So this is the reason why we come up with SDN network, because network is getting complex nowadays, and it's become challenging to manage the complex network manually. Upgrading the device, let's suppose we need to upgrade the iOS version on all devices on thousand sites. How difficult it is? It will take a week or a month, 2 months, correct? So that's why we come up with SDN network. Nowadays we need more flexible solution, right? Because we need automated solution, we need easy management system, right? Where easily I can monitor the network, easily I should have one dashboard overview of my entire network, which was not possible in the traditional network, right? In the traditional network, if you want to configure the ACL, you have to configure on all router switches manually, right? And SDN is an automated network. Through SDN you will see how we can automate the configuration, right? So if someone will ask you why we come up with SDN network, you can say complexity in traditional networks, right? In traditional network, each and every device like your router, switches, firewall is configured separately, right? So it was very difficult to add the configuration, add the new configuration, or to modify the configuration, right, to manage the network. This process was time consuming. And guys, see, if I am going to configure one IP address on thousand branches, right, and in each branches there are multiple devices, so if I am going to configure one IP address on 5,000 devices, definitely there is chance of human error, right? So to overcome these issues, we come up with SDN. Now, for example, you can imagine a company with offices around the world, each having its own network, and you need to update the operating system. We have to configure each and every devices manually, right? So it was very difficult. That's why we come up with SDN network. Then second reason can be scalability. Guys, let's suppose here in the traditional network I want to add one new branch office, right? So in the new branch office, I have to implement the devices. Then again, I have to configure each and every devices manually, right? So it will be very time consuming. It will take a month or a week, right, to set up a new branch office. So there was a issue with scalability, but with the help of SDN, right, in the SDN you can easily add the new branch offices. Then guys, the biggest benefit of using SDN is centralized control. Centralized control. In traditional network, control plane is distributed. So here you can see control plane of data center is here, right? Control plane is on devices. Control plane of side one is here, right? So if you are going to modify something in configuration in data center, you have to access these devices. If you want to modify some configuration on side one, you have to access these devices. Means manually you have to access the devices. After that you have to apply the configuration, right? So the control plane is distributed in traditional network. So as control plane is distributed, it's difficult to have an overview of entire network. Let's say I want to check health of devices. So manually again I have to access its devices, then I have to run command show process, right? Whatever command you are going to run to check the output, right, to see the output, you have to run on each and every router. The reason control plane is distributed, right? Each devices has their own control plane, correct? And this is the biggest issue in traditional network, right? So in the traditional network, it is very difficult to optimize the network, right? To apply the security policies, to modify the configurations, to add new devices, to update the operating system, right? iOS. Now guys, try to understand how SDN network works. This is very important and this is the core concept of SDN. So guys, as I told you, the biggest issue in traditional network is distributed control plane, right? So control plane are distributed. So what SDN did, SDN means separation of control plane and data plane. SDN has separated control plane and data plane from these all boxes, in data center, inside one, inside two, side three, headquarter, remote sites, right? From all the branches, SDN is going to remove the control plane, right? So if someone will ask you how SDN works, you can say SDN separates control plane and data plane. Now if you don't know what is control plane and data plane, so guys, control plane makes decision about where traffic should go, and data plane is actually forwarding the traffic, right? So control plane is taking decision where this traffic should go, where to route this traffic, and data plane is going to actually forward the packet, right? So SDN have separated these two hardware. The control plane is moved to a centralized controller, or you can say to a centralized location. So SDN separate these two types of plane. The control plane is moved to a central controller, and the central controller is nothing but a software application on devices, on the hardware. We will discuss about the hardware later. But for now guys, what I am going to do, I am going to remove control plane from these all devices, right? I'm going to remove control plane from these all devices, and I will place those control plane at one centralized location. Let's say this is my centralized location where I'm going to place the control plane. Control plane means my controllers, right? Here at this location, at this centralized location, I'm going to install some software on some hardware, right? Some hardware. On these hardwares, I am going to install some applications, and through that application I will manage these boxes, right? These are what still physical devices, but this time these devices are only data plane. There is no control plane, right? So now these devices are only going to forward the traffic. These devices are not going to decide where to forward the traffic. Who will decide that where to forward the traffic? These controllers. Now you can see I have separated the controller. Done. So the first benefit of SDN network is separation, separating control plane and data plane. Control plane is moved to a central location and data plane is remain on the physical devices. Correct? This allow the controller to manage the entire network from a single point. Now from this controller, from this centralized location, I can manage my entire network infrastructure, right? My all devices. These controllers are nothing but the brain of network. Who is going to decide where to route the traffic, right? Who is going to decide which traffics are allowed, which traffics are not allowed? Whatever control plane task earlier router were doing or these boxes were doing, now all those tasks will be done by these controllers. So that's why we are saying SDN, software defined networking, is nothing but a controller based network, right? And the meaning of controller based network is the network which can be configured, managed and troubleshoot with the help of controller is known as controller based network, right? So definition of SDN network can be the network which can be configured, managed and troubleshoot by controller. And now guys, what we can do, we can automate the configuration on these controllers, right? We can write the code, we can write the script. Fine. So the SDN controller acts as a brain of network. It has a global view of entire network, right? These controllers, I'm talking about these controllers, right? These controllers have a view of entire network and it can make intelligent decision on how to route traffic, right? So these controllers are nothing but the main brain, main control plane of my entire network. Who is going to decide where to route the traffic, right? Actually these controllers are very intelligent to decide how to route the traffic, how to manage the security, how to optimize the performance. Even we can optimize the performance of these all devices as well from this central location. Now if these devices have only data plane, so now these devices cost, right? So first thing is I have reduced the cost. Earlier at each branch, for each branches I had multiple devices and on all devices we had control plane as well as data plane, but now we have only data plane on the sides, on each sides, right? So now these devices are not costly, these devices are not costly, right? The second benefit is centralized controller. Now as I have removed the control plane and I have moved all control plane to a centralized location, so now I have what? Control management, centralized management you can say, right? The third benefit of SDN is now programmability. Now what we can do guys, now in the SDN network, or you can say SDN networks are programmable, right? Programmable means we can automate the configuration. Network engineer can use software to automate tasks, not only for the configuration, right? Even for all tasks we can automate the all task, right? And multiple softwares are available, we will discuss about those software later, right? So with the help of programmability, what we can do, we can automate the task such as configuring a new connection or changing the operating system on device or applying some security policies. or even optimizing network traffic flow. Even to optimize the traffic flow, what we can do, we can optimize this task on the controller with the help of programming, right? So this is done through APIs, application programming interfaces, making the network more flexible and responsive. Fine, guys. Now if you are thinking, Praful, okay, if you have separated the control plane from all the sides, how these means data plane, how the branch branch devices are going to communicate with controller. Now what we will do, guys, we will connect these branch offices to this service provider, and I'm going to connect both to the service provider, through which these branch devices can communicate with the controller, right? And guys, this is the reason why most of the companies are moving their infrastructure to SDN, because the first benefit is cost effective, right? SDN is a cost effective network. Here now you don't need to purchase expensive devices, you need only data plane, right? So SDN reduce the need for expensive devices, because most of the functions are managed by software. Most of the functions are managed by software in the SDN network, not by the hardware only. This reduces overall network cost, and this is the reason why most of the companies are moving toward SDN network. Now guys, this is my controller. See, try to understand it very carefully. Let me do one thing here. These sides, how we are going to connect these sides. So this, yeah, see, these are the service provider, my branches, then service provider, and after that controller. This is the centralized controller, right? Now to connect these all sides together, what I can do, I can connect my controllers to the service providers, and after that I can connect the branches to the service provider network. After that I can configure the VPN, right? You already know that. So let's suppose one transportation is internet. So I have connected internet public public service provider to data center. I'm also going to use MPLS, right, for the backup. So now my controller is connected with the service provider, and now I can connect my branch offices to the service provider network like this. Fine, guys. In the same way, I can connect these sites to the another transportation as well, like to MPLS. And here I have only few sites. In real time you can have 1000 number of sites, and you can have multiple transportation, not only internet and MPLS, more than 2 as well, right? Definitely you will not have one transportation if you are using SDN, right? If you are using SDN, that means you have some critical application, critical data, right? You can have more than 2 transportation as well. So this will be my design. So this is my controller, or you can say my controllers, who is going to manage control plane, controllers which will manage control plane, And now guys, on this controller, what I can do, I can automate the task. Now I can automate the task. I can write the code. Let's say I want to configure one ACL on all the devices. So what I will do, I will write the script for that ACL, and through these controllers I am going to push that configuration on all devices in 1 second. I can push that configuration on all devices in 1 second, right? So now it's very easy to automate the configuration, as SDN is a programmable network, so we can automate the task. And guys, after that we can push the configuration from controller to these boxes, right, which are located at my sites. So this is SDN network and how SDN network works. Now guys, why companies are moving towards SDN? So the cost effective, because you can see as I have removed the control plane from these boxes, cost is automatically, guys, reduced. It reduced the need for expensive devices. Now I don't need to purchase expensive devices for my branch offices, for my data center, for my remote headquarters, for my remote sites. These are cheap devices who are only going to manage data plane. And even we have reduced the overall cost of network, because in the SD, then it is flexible. Easily we can add the devices, we can add the branch offices, right? We have enhanced more security here. In a single second, within a second, I can push security policy on all the devices, right? And then next benefit can be automation and speed. With the help of automation, we can automate the task. Now guys, types of SDN network. Types of SDN. Type of SDN network is, see, first of all, how we have divided the SDN network. So guys, always keep in mind, we categorized SDN into different types based on how control plane and data plane are implemented and managed. How we are going to implement control plane and data plane, and how we are going to manage it. On the basis of that, we have divided SDN into some types, and the first one is open SDN. Open SDN. Open SDN is, you can say, it's rely on open protocols. The most common is open flow. The most common is open flow. Open flow protocol to communicate with data plane and control plane. How data plane and control plane are going to communicate with each other? With the help of open flow protocol, right? Definitely these guys need to communicate with each other. Let's suppose in the data center I have one subnet 10.1.1.0/24. So now data center is going to advertise this prefix to the controller, and controller is going to advertise it to other sites like this. Okay, through the internet, through the MPLS. MPLS can be primary, internet can be secondary, right? So with the help of open flow protocol, my controller and my data plane devices, my branch devices, are going to communicate with each other. The next type of SDN is SDN via APIs. Application Programming Interfaces, APIs. So this type of SDN uses APIs provided by vendor to interact with networking equipments, right? So there are many vendors in the market who is providing this solution. So they are, and these devices, branch devices, are going to communicate with each other through APIs. And who will provide you the APIs? The vendor company. Then guys, the third type of SDN network is hybrid SDN. Hybrid SDN, see, this is like combination of traditional network and the modern network. Some part of network are managed by traditional method and some part of network are managed by SDN. Like let's say I want to manage my data center only through SDN, right? Because I have critical network there. So we can have SDN controller for critical part of network like your data center, and rest all will be following the traditional method. And guys, the fourth one is cloud. You can say SDN in the cloud. Same guys, in the cloud what will happen? We'll store the install controller in the cloud, right? So this is the basic about SDN network. Basic about SDN network. So guys, there are many more things, and if you want to master the SDN network, no worry, I can make one separate playlist for this course. Just let me know in the comment section. Just share your feedback, right? How it was, guys. If it was helpful for you, if you like this video, if you have learned something from this video, right, please let me know in the comment section. Just type yes. Once you will type yes, I will get to know yes, this video was helpful for you, right? You need more videos like this, and I will try to upload more videos on SDN network. So that's all for today, guys. If you have learned something from this video, now please hit on like button. If you have any question, query, concern, please let me know in the comment section. If you have not subscribed the channel till now, please subscribe this channel, and we'll meet soon in the next video. Till then, stay safe. Bye bye. That's all for today. Thanks for watching.